I'm going to try to calculate the standard deviation of x. So the random variable x, and sigma again is our symbol for the population standard deviation. There will be no sample here, we're just looking at sigma. And sigma of x is found using this formula here. These are equivalent formulas, they'll get you the same answer, they're done in a slightly different way. I typically use the first of which, the one on top, if I've got a small amount of data points, small amount of values of x, and I use the bottom one if I've got a whole bunch of them. That's if I'm forced to calculate them by hand. There's a calculator function which I'll show you in another episode. So we need the value of the mean of x, and we take each value of x, subtract the mean off, square that so we'll have a positive value, and multiply it by its corresponding probability. Just a slightly larger formula than we did for the mean. This is the same data that we used before. If you recall, the mean of this distribution of x was 1.49, so we're going to use that in each area where we deal with the mean. Alright, so I've set up a little chart here of how you might want to look at breaking down that formula. The different values of x are right here. The mean again was 1.49, so the mean doesn't change, it'll be the same within the entire column. Now this is how much x deviates from the mean. So x minus the actual mean will give us these values. Once we square them, they all become positive, and ultimately we need to multiply the squared deviations by the probabilities. The probabilities, this p of x has been taken from the previous chart. These are all the values of the probabilities at the given values of x. So these are the squared deviations multiplied by the probabilities. So the variance is the sum of those. And if you recall the relationship between the standard deviation and the variance, we have sigma squared as the variance. Sigma to the first power, or the square root of sigma squared, is how we would find the standard deviation. Thus we'll take the square root of this 0.8699 to find the standard deviation, which comes up to 0.9327.